Welcome back, everyone. So today we will start chapter number 3. I have divided this chapter into two parts, and today we're gonna talk about the first part where we will be talking about network topologies. We will discuss the definition of network topology, like what does it mean when we say network topology? What does it mean? Then we will discuss a couple of types of network topologies, and we will also I'll give you an overview of network technologies, the definition of network technologies, why do we use it, and things like that. In the detail of network technologies, basically there are two network technologies. Like one is Ethernet. I'm talking about for local area network and Wi-Fi. For wide area network, we can use SONET, ATM, frame relay. These kind of things are for wide area network. Our focus is going to be local area network technologies. This is what we will be talking about in part 2. So today, the main agenda item is network topologies. So let's get started with the definition of network topologies, and then we will discuss different types of network topologies. And I'm quite confident after this particular video, this lecture, your network topologies topic would be covered once for all. All right. So first of all, what is network topology? So whenever you see this term network topology, it means we are talking about network topology, if you see this particular term, what does it mean? It means we are talking about the design of the network. The design of the network and typically physical design of the network, like how the network will look like. So how network will look like. So this is basically what, whenever you see the term network topology or network topologies, like how the network is going to look like. For example, let's understand it with example. Let's say I have 4 PC. Let's say this is my PC 1. I have another PC 2. This is another PC 3, and that's the PC 4. So I got, for example, 1, 2, 3, and 4 computers. Now, question is, I want to build a network. I want to design a network. So my question is how I can connect my 4 computers, how these computers can be connected in order to form a network. So if you want to design the network, you want to connect computers with each other, here the topologies come in. So what are the options that we got? One of the option is I want to build a network. One of the option is I can actually place all these computers. 1, this is computer 2, this is computer 3, this is computer number 4. I can connect them together like this in a straight line. I mean, this is one of the possibility. This is the first option. I can connect them together with a wire or something. Second option is I can, for example, leave them as it is, like in the same fashion, and I can connect them like this. Okay. Another option is I want to make a network. This is the second option. Another option is I can, for example, get a device like a hub. We already know what is a hub, or we can get a switch, and I can connect these 4 devices with these hub. Like these devices are connected with each other with this particular networking device, a switch or a hub. So there are a couple of possibilities. This is our third option. So this is basically called a network topology. So network topology, whenever you see this term, so the term network topology is physical description. Network topology, it means physically how the network will look like, physically how network will look like how these computers are connected together, how the network will look like. So we call it network architecture or design of the network. So let me give you another idea to look at the network topology, because in our book we have also discussed that network topologies can be of 2 types. Like for example, if you want to design a network, now, beside physically, there is another option, that the way how we can categorize the network. And what are those options? This is called physical topology or logical topology. So a network topology can be interpreted as physical topology, or maybe the logical topology. So physical topology is the one which we are talking about. Physical topology means how your computer network physically looks like. So how your network, or simply you can say your network or computers look like when you, for example, connect them together, when we connect them. So when we connect the computers to form the network using a hub, maybe for example, in a line, if you guys see this example, in a line, for example, in a sort of a ring, in sort of a star. So that's basically what the physical topology is. For example, in a line, for example, in a star shape, or for example, in a ring shape. So this is basically what the physical network topology is. Beside the physical topology, and again in the book you will see the network topologies like by ring, mesh, and all those are basically physical topology. But beside the physical topology, there is another, like, which is interpretation of the topology, which is logical topology. So logical topology means, for example, let's say it looks like, for example, it looks like you have connected the devices, like for example devices, by using a hub, and you can see it looks like a star, but internally they might be using a ring, or they might be connected with a bus. Are you getting the point? So basically logical topology is, apparently network may look like connected in a ring or connected in a line, but they might be connected using a star topology inside. So logical topology is basically the interpretation, or you can simply say in logical topology, computers physically, like using a physically, for example, physically connected in, for example, let's say a ring format or a ring method ring format, but internally devices are communicating with each other, or sending out the data, communicating or sending information using, let's say, star methodology, okay, etc. Like they are basically using a different methodology other than what it physically looked like. Like physically a person looked like a good guy maybe, but you don't know, he might commit some crime or something like that. So that's basically what the logical is. Logically means like how actually the data is basically moving out, how data is traveling, how actually the data is traveling over the network. That's basically what the logical topology is. Okay, as I mentioned earlier in our book, and whenever you guys see the term topology, it means we are talking about the physical network topology. And there are 6 types of network topology which we are going to discuss today. The first topology which we will discuss today, it's called mesh topology. Another network topology that you guys will see over and over this term, that is bus topology. Another one is star topology. Again, these are physical, but again, interpretation can be translated into logical as well. Then we got a tree topology. Then we have a hybrid topology as well. Hybrid, and I think I'm messing with one, and that is ring topology. So these are the ways how computers or network can be designed, how you can make the computers to communicate, how you can connect the computers. So how you can connect the computer physically, how you can connect computers physically, okay, in order to form the network. So we got these 6 main methodology. The most common one, you might have a question, which is the most common one, or what exactly we use in the local area network. Typically the star topology is the one which we commonly use. This is the most common. After star, bus and mesh topology come after the star topology. It doesn't mean that we don't use ring, we don't use the hybrid or tree or ring. We do use them, okay? So I'm going to actually explain you all these topologies, their infrastructure, how we can design them, and then we will discuss the pros and cons and where exactly we use those, okay? So let's start with the first topology, and that is the mesh topology, mesh. So let's see how mesh topology, how computers can be connected by using mesh topology, okay? So let's start. So I put together a few things to consider here, but I'll explain you with a diagram so you will never forget about the mesh topology. Mesh, as the name suggests, it's basically kind of a net. Like it will basically design a network, okay, where every computer will be connected with the other computer in the local area network. I'll explain you all these points in a bit, But let me just take a diagram so then it will make more sense to you. So for example, I have 4 computers in my local area network. So I got 4 computers, 1, 2, 3, and this is my 4th computer. So 1, 2, 3, and 4 computer. If I want to connect them by using a mesh topology, I'm going to connect them with, all the computers will have a dedicated line, straight line, a dedicated line with other PCs. Like the data will not travel through computers, but with a dedicated line. Let's say one wants to send a data to two, there would be a dedicated line. And again, if two wants to send a data to one, they can use the same dedicated line. Then if one wants to send the data to 4, there would be a dedicated line. Same case, if 4 wants to send the data, that dedicated line can be used. Similarly, if 2 wants to send the data to 4, there is a dedicated line. And if let's say 2 wants to send a data to 3, there would be a separate dedicated line. And similarly, otherwise, like 3 want to send to, same thing. If 4 want to send a data to 3, there would be a dedicated line. And last but not the least, if 1 or 3 wants to communicate with each other, there would be a dedicated line. So if you guys see here, every computer, let's say 1, 2, 3, 4, has basically a dedicated line with every PC, and that's what I'm telling here. Every computer connects to other PC. There would be a dedicated line. So every computer got a dedicated line. So if computer 1 wants to talk to 2, there's a line. 2 wants to send the data, so they can use the same line. So data will travel with a dedicated line. You guys can see here, these are connected. Let's say, for example, if this particular line, let's assume that this particular lines, for example, got dropped. But still the data, 1 can send the data to 2. How? They can forward the data. 1 will forward the data to 4, and through 4, the data can be transmitted to 2. It will still work. So that's why we got a high level of redundancy. We got what we call more options, multiple paths. So we got multiple optional paths. So the network which is designed by using mesh would be more reliable. If any of the path is down, so it does, or for example, this cable got cut, it doesn't mean that the 2 is out of the network. It cannot communicate with other computers. It's still, because we got high level of redundancy. And this particular technology is very common in wide area networks. So we use it for routers, where routers can communicate with each other. The only problem with the mesh topology is, if you guys see, I have only 4 computers connected right here. Just imagine if I have 100 computers. Or let's say if I have, assume that I got, let's say, 1,000 computers. So just imagine how many wires you need, how many wires we need, or you can say cables we need. For example, troubleshooting would be a problem. Let's say if any of the computer is not getting the data or something, troubleshooting is going to be very complicated. So things are getting very complicated. We need a lot of wires. So of course, it's going to increase the cost. Troubleshooting, if, for example, this particular link or this link is down, so it would be very hard, because in the 4 computers, it seems easy, but if the size of the network is large, it's going to be very complicated. Typically, we use the mesh topology. This particular topology, we don't use this topology, the local area network, but this topology is typically used for wide area networks. So routers, they typically use mesh topology just to design the routes. So there are plenty of routes, and they can find out the best path, and they put those particular path, like, because we got multiple path here, so best path would be added to the routing tables. So routers, they basically use different algorithms. And create the best path. So the con of this this particular topology is, it's going to be very costly plus complicated design. For each computer, there should be a dedicated link to all the computer. Let's say if you have one computer, it want to connect with 100 computer, there should be 99 cables. Or for example, 1000, so 999 cable for each computer. So that's basically make it very complicated and costly as well. Okay, because each time you need to deploy a dedicated path. dedicated path for each particular computer. Okay. So that's why this technology or this particular topology is not common in the local area network. So the next topology, so this was basically the mesh topology. Now let's talk about the bus topology. So bus topology, if you guys see this, I just actually designed a bus topology for you guys. This is called terminators. These are terminators. And if you guys see this black line, this is basically called a bus. Bus, or technically it's called a trunk cable. It's basically a trunk cable. We call it a trunk cable, or you can say we call it a bus. Okay. So if you guys see here, the benefit of this, or for example, how easy to design this. So we just have laid down this particular cable, and all the PCs are connected with each other by using this cable. I mean, they are connected with each other. This node is called T connectors. T connectors. So we got, if you want to connect new computer, you just have to put a T connector with the bus, and it would be connected, or it would be a part of the network. So if you want to install the new computer, place a new T connector, and you can connect a new computer. So adding the new device are going to be very easy, and you guys can see here it's simple to design. But the biggest challenge is security problem. Why security problem? Let's say if this computer 1 wants to send a data to this computer, let's say 10. So this data will travel through this wire. They will also get the packet. They will also get a copy, and he who is the actual receiver will also get a copy. So it doesn't offer any good security. So no security at all. And of course, there would be a lot of traffic inside. Okay. Typically, this bus is like we use a Ethernet or a cable or Ethernet, where that's basically what is more commonly used. And there is no dedicated line. So of course, if there is no dedicated line, so it means, of course, you guys can see all these are connected with a shared line. So very less number of cables. So it is less costly as compared to the mesh network. Okay. And there is just a centralized cable. Dedicatedly, we have placed a centralized cable. So there is just a centralized cable. Everybody has to share that particular cable. So there might be a problem of collisions. So we need to use some sort of the collision avoidance methodologies. Like for example, if this computer wants to send a data, and in the meanwhile, and forward a data, let's say this computer wants to send a data 10. This is the packet. Let's say this is the packet. And in the meanwhile, this computer also try to transmit the packet to any of the computer. So then there would be a possibility of collision. So we need to use some collision algorithms to avoid it. And another problem is, let's say, for example, if this cable got blocked or damaged, then overall network would be down. Okay, so install it when you add a new device, your bus will be down. Your network would be down when you install the new device. So I put all these things together here for your understanding. So use a trunk or backbone to connect all the network. We talked about it. Again, systems or computers connect with these T connectors. These called T connectors. You don't need any kind of dedicated device. You don't need any switch in order to connect them. You don't need any kind of hub. And that's why which make it insecure as well, because there is no control of the packet or access of the devices. It requires less cable because just one centralized cable, all the devices can get connected with that. It doesn't require any specialized device. This is what I talked about. We don't need any kind of switches. We don't need any kind of hubs. Straight away, devices can be connected with the T connector. That's it. So of course, it would be less secure. Okay. And again, everybody will get the copy because we are sharing the bus. There is no dedicated path, no dedicated path. So of course, we are sharing the big cable or the bus. So that's why everybody will get the copy. So you can say it will basically, the packet would be broadcasted. Okay. Whole network goes down if trunk break. Okay, so if one of the cable goes down, the whole network will be down. And one thing is, let's say if we add a new device, new device, then cable or the bus network has to be down. Network will be down for that time. So like while you are installing or adding a new device, your cable or your network would be down. So this is the bus topology. You guys, if you will have any question, you can also bring up in the class. All right, so let's move on to over, and this bus topology, it is suitable for only the small networks. Small networks, it's fine, you can use it because we are using a centralized cable to connect all. But for large network, of course, it's going to be very complicated. Not complicated, but it will be compromisable. Next, we got star topology. That's the one which is most commonly used. So this is the most commonly used technology, most commonly used for local area networks, or even for metropolitan area network. We use that particular one, which is extended star. So in metropolitan area network, we typically use the extended version of star topology. Very simple. If you guys see this diagram, you can see here we have a small centralized network device. All the computers are connected with this centralized device. Okay, so all computers, PCs, don't have to get connected directly. No direct connection. No direct connection. No directly connected. They are connected through the networking device. Okay, so for example, if this is PC1 wants to send this packet to PC4, so this packet will be forwarded to the networking device, and networking device will forward the packet to PC4. Okay, so there is no direct connection. So we can also if rather than using hub, and you guys know that the problem of hub, because it's going to broadcast, so you can also replace this device with a switch, which is an intelligent filter. Another thing is, for example, if this cable fail, so only this computer will be down, not the rest of the network. So other will still communicate, but overall network will not be affected. And we can easily make a large network. We can easily add the new devices. Typically, there are 48 ports in a Ethernet switch, 48 ports in a switch. So 48 port means 48 different computers can be connected. Okay. Yeah, and again, without compromising the overall network. So in the star topology, I just put all these things together. I think it will make sense now. All computers connect to the centralized device, which is basically switch, or it could be a hub or hub. So our devices are connected together. Okay, each device require a single cable, like this cable, which could be an Ethernet cable, or you can even use any category cable, in fact, depending upon how much data rate you want. Most widely implemented, I already told you guys, cable failure, only if the cable get failed, only that particular device would be affected. Easy to troubleshoot. For example, if this computer, let's say that computer is not getting signals, so we can easily navigate, we can easily find out what's the problem. So without compromising over the network, we can add new devices, unlike buses where the overall bus network will go down. Okay, so if computer 1 wants to send a data to, for example, 4, so as you know, it's going to drop it to centralized network device, which will forward it. We can extend this star topology, the extended version of star topology, which is very simple to design. So let's say I have a big network, so I can place a switch in between, big local area network, and I can connect, for example, 4 switches. That's it, something like that. If you guys see, it is again forming a sort of a star, you guys can see. And again, with these kind of switch, I can have multiple, let's say this is local area network 1 segment. Okay, there could be multiple devices connected with all these. Okay, so this is called extended star. Extended star, in order to form a big local area network, or even the private metropolitan area network. All right, so number 4 is the ring topology. If you guys see here, ring topology, as you guys can see here, the data is basically move in a typically it moves in an anti-clockwise direction. Let's say 1 wants to forward the data will be first forwarded or passed on to number 4. Let's say data has to be traveled from 1 to 3. So data will firstly go to 4 and through 4 to 3. And if any other computer wants to transmit the data, it will go in a circular fashion. Okay. So, and biggest challenge is if the cable get break, overall ring network will get compromised. In this ring network, mainly we use the token ring. It's called mainly token ring. Token ring topology. Why we use this term token? To avoid basically the collisions. Because again, all these computers are mainly used, they are using the shared path, or you can say shared cable. So if they are using a shared cable, so there can be collision again. So if there can be collision, so in order to avoid collision, we use a token. And how this token actually work? Let's say, let me give you an example. Let's say, for example, this computer got a token first. Token mean this computer has a right to send the data, to send data. Send the data. And let's say this computer want to send the data to computer 3. Okay. So one want to send the data to 3 and it got token. So what does it mean? It means no other computer will send the data when this computer got a token. It will forward the packet to 4. So it will go from 1 to 4 and 4 to 3. And then once the 3 will get the packet, then the token will be passed. This token will be passed on to the next computer, number 4. It got a token. No other computer will communicate during that time. No, because computer 4 got the token. Now, if computer 4 want to send the data to 1, it's not like that. It will not go back. Not this way. It will forward the packet. Let's say this is the packet. Packet will go to 3 to 2, and then it will go to 1. It will go in a anti-clockwise fashion. I mean, that's not the way how it will it can go back. Ring topologies are typically, I mean, you can use in a local, you can design a local area network by using ring topology. Very simple. Let's say something like that. Let's say I have, this is my switch 1, this is switch 2, this is switch 3, and this is switch 4. And I can have multiple computers connected with all these. Again, all these might be connected in a ring. You can design a simple local area network. Let me draw this so it will make more sense to you all. Like, typically, if you want to design a local area network by using ring topology, so how you can do that? So I can actually place switches here or hubs. This is my switch. S is for switch. And with these switch, for example, I got 3 computers connected. I have, for example, 2 computers connected here, 2 computers connected here, 2 computers connected here. Okay. So if you guys see, this is kind of a hybrid model. Okay. And if you see, it is basically forming, I mean, you will say that logically it looks like a ring, but again, it might have a ring methodology because you got a centralized device involved to connect the device, actually the devices, like nodes, in fact. This is going to give you the best explanation of the logical topology. So how it looks like, I'm sure you'll say it looks like a star topology. It looks like a star topology, but if you guys look at how the data is being transmitted, so here we are using a device which is called MSAD. This is a circular device called MSAD. MSAD, it stands for multi-station access point. So multi-station access point. So this multi-station access point basically controls or issues token. It issues the token to each station, each workstation. So for example, let's say this computer is computer 1, that's 2, and this is 3, and this is, for example, 4. So if you guys see, apparently if we see physically, it looks like a switch. But since we have implemented, or internally, we have put the ring topology in it by using MSAD. Now, what is going to happen? One want to send the data, and one, for example, got the token. One want to send the data to 3, 1 to 3. How the data would be transmitted? Data will forward from 1 to 2, 1 to 2, and again anti-clockwise, and then 2 to 3. Now, if 2 wants to send the data to 1, again, it will not basically go back in this direction. It will go firstly to 3, and then 4, and then 1. So 2 to 3 to 4, and then 1, even though 2 wants to send the data to 1 directly. Okay, but this is the path it's going to take. And each particular station has to wait for its token in order to communicate. In order to communicate, once they get the token, then only the packet can be transmitted. Okay. So this is, by the way, the ring topology. Next is the hybrid topology. And hybrid topology is basically where we can use 2 or more topologies. For example, let's say I have a bus. Let's say this is my centralized bus. And with this particular bus, this is, let's say, a bus, and I have connected this segment, and let's say I have a switch here, and with this switch I got 4 devices, and again you can see this is the star topology. Okay, and another segment here is where I have, for example, 4 computers connected in a ring. Now what you will call this particular network? We call this network as a hybrid network. If you see, we have bus topology here, We have star topology here. We have the ring topology here. We have multiple topologies right here. Now you might ask a question, where do we use it? Now, for example, the local area network was already deployed. It was the existing local area network. Okay, you got this particular segment which is connected with a star like this, and you got another segment connected in a ring. Okay, so one was star, one was ring. Now you want to connect them. One of the option is you can also make it a ring, or you also make it star, or you can make it a ring. Second option is you can leave it as it is and just connect it by using a bus. So you have already existing network in place. You don't want to invest in, and you want to connect the existing local area networks. So what we did, the better idea is if we use a bus. So this is basically over hybrid topology. Okay, existing network, you don't want to spend a lot. The last topology is the which people they do confuse the tree topology with the hybrid topology. But in tree topology, we basically form a tree. We make basically the nodes and the root. So mainly we use star and bus topology. And how it looks like, it's not hybrid. First of all, please remember, it is not hybrid. It is a separate entity which involves star and bus. So you can say extension of star and bus. Okay, how? So let's say we have here a bus, and for example you have this switch or the hub, whatever the networking device, and couple of devices connected with that. Okay, so I have this local area network. Rather than putting a new switch in, what I did, I have placed a common bus, and then let's say this is another networking device. I got switch, and these are my other segment of local area network. This is another segment of local area network. So if you see, we have only two topologies here, which is star. I have connected my different segments of local area network with the bus. So where do we use the tree topology? We typically use the tree topology to design large local area networks. For example, this is your marketing office or marketing building, and let's say this is, for example, your sales building. Okay, or for example sales departments, you just connect them together. So, or you can also use it to build the private metropolitan area network. Okay, and it's very easy to add a new network. How? All you have to do is connect with a switch, with a cable, and then you can of course connect the new network as well. So these are the network topologies. We have discussed mainly 6 network topologies here. We have discussed what is a mesh topology. We talked about the pros and cons and how where we use the mesh topology. We know that mesh topology bring diversities. We got multiple network. It is reliable but costly. Okay, not recommended for the local area network, used in wide area network. Bus, where we got single bus problem, it is insecure, shared network, more chances of the collision. Ring topology, of course, chances of collision. To avoid the collision, we use tokens. Okay, we have used the token methodology where whoever got the token, they can only transmit the message. Star topology, the most commonly one, devices, there's basically one centralized device, switch or hub, devices are connected with that. Tree, which basically extension of a bus and stars. So star plus bus basically make a tree where you want to make the large local area network. Hybrids, where you can put, for example, you connect all these 4. You got existing network. You don't want to change the whole infrastructure. You can connect them by using a bus. So let's move on to the last agenda item, which is the network technologies. And again, I'm not going to give you the whole details. We're going to discuss the network technologies in detail in next class. I just want to give you the definition of network technology. What is that? And then we will talk about some basic network transmission media. So network technology. First of all, what is the network technology? How do you define network technology? Network technology is nothing but it's basically a method. Like you have network interface card, for example. Let's say this is your computer, how it transmit the data. If you want your computer to transmit the data, how you can connect it. Let's say this is your PC or laptop. You want to connect your laptop with your access point or Wi-Fi, or for example, the router. How you can connect it? Sorry about that, not router and all. So one of the ways we can, for example, connect it by using the cable. Or second option is we can, for example, connect it by using a Wi-Fi. Network interface card would be wireless or it would be a wired. In the case of wired, we need to put a cable, connect the cable, Ethernet cable, all the way from your interface card all the way to router. In the case of wireless network interface card, we need to just connect it with the right frequency, put the password and all that. So these technologies, how do we connect them? The interfaces, this would be, the cable base is called Ethernet and the wireless base is called Wi-Fi. That's what we're going to talk about. These are the network technologies. So definition of network technology is basically the method network interface. Network interface like means how it your computer will connect to the network uses. So method your network interface uses to do what? Access the medium. Now access the medium. Now this particular medium could be wired, guided medium. It's also called guided. We'll discuss that. Or unguided, which is wireless. Like the signal can go anywhere. But for example, just imagine if we got a wire, we got a guided medium. We know that we need to travel through this. Unguided is wireless because this is air. You don't know where to go. So we will discuss the network technologies. Basically tells how to access the medium. For example, how to send frames, how to send data frames, which is basically source address, source and destination MAC address per IP address, plus how to structure the frames. Structure frame, like what do you need to put it inside? Because Ethernet frames are different. Ethernet frames are different than the wireless, the Wi-Fi frames. We need to talk about these frames as well. These network technologies are also called network architecture. Some people, they call it data link layer technologies and things like that. These are the same thing, by the way. And these network technologies can be Ethernet, as I talked about, Ethernet, which is wired, or it could be, for example, Wi-Fi, which is IEEE. That's the standard for Wi-Fi. IEEE 802.11. This is the Wi-Fi standard. We'll discuss all the standards, or you can combine these. This is for local area network communication. Again, for local area network technologies could be Ethernet or Wi-Fi. But for wide area network, these technologies are frame relay. We got a different technology here, or it is SONET, or there is another technology called ATM. So there are different technologies for wide area network. So I'm going to actually give you just, we will discuss Ethernet in detail in next class. We will discuss the Wi-Fi and all the standards in the next class. I'm just going to give you, for example, if you use a Ethernet. So if you decided to use Ethernet technology, the transmission media, what sort of different transmission media we got from where the data can be traveled. Okay. We have a complete chapter on these wires, cables, which is chapter number 4, the next chapter. But here I just want to give you an overview. UTP is one of the most commonly used transmission media through over which the data can be transmitted. This is the example of UTP. You guys can see here the 4 twisted pair cable. One is carrying positive, second is negative, positive, negative, positive, negative, the signals. And this is basically called a UTP. Most common type, this is one of the most common type of transmission media in local area network. Okay, and typically the UTP, it has mainly the 4 pairs. If you guys see the 4 pairs of cable, and these are twisted pair cable. If you, for example, increase the cable, let's say if you put another cable here, another twisted pair cable, it will be called category 5 cable. Category 5 means there are 5 pairs. Then there would be a cat 6 cable where you have 6, for example. Okay, so if you increase the categories, automatically you are increasing the bandwidth. If you are increasing the bandwidth, it means more data can be transmitted. So more data can be transmitted means higher data rate. Okay, so high data rate, again based on how many how many pairs of twisted pair you got. That's UDP. We'll discuss that. Unshielded twisted pair, it's called unshielded twisted pair. All right, next is fiber optic, another way to transmit the data. Fiber optic, as name suggests, it is basically made of glass material, and data travels in the form of light. travels in the form of light. Form of light. So for example, you want to transmit the data 1, so you can turn on the light, 0, no light, 1, light on, something like that. That's the way how it works. Coaxial cable, we will see that in our class. In coaxial cable, two cables are basically mounted onto each other. That's what it's called. So if two cables are mounted onto the same axis, such cables are called coaxial cable. These are kind of obsolete for local area network. We don't use them anymore, but still we use the coaxial cable to connect the modems. So to connect the modems, we typically use the coaxial cable. They got higher, larger bandwidth. So these are good to carry the internet signal. And probably at your home, if you have not upgraded to fiber optic, you might still have the coaxial cable. Last for today is the baseband versus bandpass signal. We will discuss that in detail. Just for simple understanding, baseband signals are basically those where if you want to send 0 or 1, you got only two options. You will, for 0, absence of the pulses, absence, or here you get actually presence of the power, electric power, electric pulses or electric power. And again, this is for low frequency signals. So we transmit the signal at low frequencies. Typically it is within the data. And for the fiber optic broadband signals, let's say you want to send 0 or 1. Here we got multiple values. We have multiple range of the values. We will discuss that in detail in our class, but I just want to actually give you an overview of transmission media and the network technologies. So just to sum up, in network technologies are basically those technologies which decide how to transmit the data now. How to transmit the data. So to transmit the data, we can use guided medium or we can use unguided medium. Guided is basically Ethernet and unguided is basically the Wi-Fi or wireless for local area network. And this is for wide area network. We will discuss that later on. So that's it for today. If you will have any question, please let me know, or we'll have a discussion on this video in our class.